Ask an AI to prove something genuinely hard in mathematics, and it will hand you a beautiful, confident, perfectly formatted proof that is often completely wrong, fluent nonsense. And yet, in early 2026, an AI helped crack a real open problem that had sat unsolved for decades with a genuinely new argument. One of the greatest living mathematicians looked at it and vouched for it. So what changed? Here is the twist, and it is the whole story. We did not teach the AI to stop making things up. We gave it a referee that cannot be fooled. Let's open it up. Start with the problem, because it is deep. A language model is a prediction engine. It writes the next word that sounds right, based on everything it has read. Ask it for a proof, and it produces text that looks exactly like a proof, with all the right phrases and symbols in all the right places. But sounding right and being right are not the same thing. It can confidently skip a step, assume the thing it is trying to prove, or invent a fact that simply is not true. In most writing, a small slip is forgivable. In a mathematical proof, one broken step and the entire thing is worthless. So you cannot just trust what the model says, you need to check it. And here is the beautiful part. Mathematics has a way to check a proof completely mechanically, with zero human judgment. It is called a proof assistant. The most popular one is named Lean. In Lean, you write your proof in a strict formal language, and a tiny trusted program reads it and asks one question of every single step. Does this actually follow? If every step holds, it compiles, and the proof is certified correct. If even one step does not follow, it fails. No partial credit, no close enough, no being talked into it. The checker does not care how confident or fluent you sound. It only cares whether the logic is airtight. Now put the two together and you get the idea behind the whole breakthrough. On one side, the language model, a brilliant, fast, wildly creative proposer that also lies. On the other side, the proof checker, a referee with no imagination at all that is impossible to fool. So you let them dance. The model proposes a proof. The checker tests it. Wrong ones get thrown out instantly. Verified ones are kept and fed back to make the model better. Propose, check, keep only what survives, repeat millions of times. The AI can explore a vast ocean of ideas, most of them wrong, and never once accept a bad one. Generate and verify. You can watch this get real at the Olympiad, the hardest math competition for young people on Earth. In 2024, a system from Google DeepMind reached silver medal standard, solving 4 of the 6 problems with fully machine-checked, lean verified proofs. In 2025, AI crossed the gold medal line. But here is the honest footnote almost every headline skipped. The famous gold medal runs were written in plain English and graded by human judges, not verified by a machine. Impressive, absolutely. But only the systems that wrote their proofs in Lean were truly checked step by step. Same score, very different guarantee. Always ask which one you are looking at. Which brings us to a cautionary tale you should know before you cheer. There is a famous list of open problems left behind by the mathematician Paul Erdős. In late 2025, a lab announced that its AI had solved 10 of these long unsolved problems. It made huge headlines. There was just one issue. It had not solved them. It had searched the literature and found papers where humans had already solved them years ago. The problems were only listed as open because the person maintaining the list had not seen those papers. The claim was quietly walked back. The lesson is sharp. Finding an answer that already exists is not the same as proving something new. When you hear solved, always ask solved or merely found. So now you can appreciate what actually happened in January 2026 and why it was different. Another Erdős problem, number 728, genuinely open. This time, the AI did not go looking for an old answer. A frontier model proposed a real, new argument, and then that argument was written out in Lean and checked, line by line, until the referee confirmed every step. The machine that makes things up, kept honest by the machine that cannot be fooled. Terence Tao, one of the most respected mathematicians alive, looked at it and vouched for it. That is the generate and verify loop, working on a real piece of unsolved mathematics. But do not let the magic word verified switch off your brain, because there is a subtle trap hiding inside it. The checker guarantees one thing, and one thing only, that the proof matches the statement written in Lean. It does not guarantee that the statement is the right statement. Someone, or some model, has to translate the real-world problem into that strict formal language first. And if that translation is subtly wrong, if it quietly proves an easier or different claim, then the checker will happily certify it. You get a perfectly verified proof of the wrong thing. The logic is airtight. The question might be off. That last mile, from a real problem to the exact formal statement, is still a human's responsibility. So let's be honest about where this really stands. What these systems mostly do, brilliantly, is rediscover and extend techniques that already exist. Winning a gold medal is stunning, but Olympiad problems have known answers and a clean structure, and a time limit of a few hours. Real research has no answer key and no time limit. Even the genuine new proofs so far have been on the easier end of what is open. Tao himself, after that January result, cautioned that it said more about speed than about difficulty, and estimated that only around 1 or 2% of these open problems are within reach of today's AI. This is a powerful new tool. It is not a machine that has surpassed human mathematicians. And there is a quieter revolution underneath all of this that has nothing to do with hype. For years, mathematicians have been rebuilding known mathematics inside Lean, brick by brick, in a shared library called Mathlib. It now holds well over 200,000 proven theorems, the largest body of fully checked mathematics ever assembled. They do it to catch hidden mistakes and to let thousands of strangers collaborate on one proof because a contribution either compiles or it does not. Tao's own group formally verified a major theorem this way in about 3 weeks. That same tireless checker, the one built to catch human errors, is exactly the referee that finally makes an AI's maths trustworthy. So step back. What does it all really mean? Strip away the breathless headlines and something genuine remains. For centuries, the bottleneck in mathematics has been checking, slowly, by hand, whether a proof is truly correct. A verifier that never tires, never skims, and can never be fooled quietly changes that entire economy. Tao describes it as mathematics moving from an age of proof scarcity toward an age of proof abundance. But hold both truths at once. The AI still hallucinates. The verifier is the only reason to trust a word it says. The direction is real, and it is exciting. Anyone who tells you the machines have solved mathematics is selling you the fluent, confident version of being wrong. So the next time you see a headline that an AI cracked some famous problem, you now know the 2 questions that cut through the hype. First, was it actually verified, or did it just sound convincing? And second, did it prove something genuinely new, or did it find something we already knew? Holding both the real progress and the real limits in view at the same time. That is the whole point of this channel. We take the machine apart so the hype cannot fool you. If that is how you want to understand where AI is truly going, subscribe. There is always another proof worth checking.